Now, in all our previous lessons, we have learned using SOHCAHTOA. We have also learned special angles, where we had a table representing the sine, cosine, and tangent of 0 degrees, 30 degrees, 45 degrees, 60 degrees, 180 degrees, 90 degrees, 270 degrees, and 360 degrees. And we understood the sine is equals to opposite over hypotenuse, cosine is equals to adjacent over hypotenuse, tan is equals to opposite over adjacent. And we have also dealt with equations whereby we were given maybe two sides and an angle. Let's say angle 30 degrees, we are given x and y, and let's call this z. So we can evaluate these two sides given when we're given a side, because we understand that sine 30 degrees will be equals to x over y, because x in this case is the opposite, y in this case is the hypotenuse, and z is the adjacent. If sine 30 is equals to x over y, that is opposite over just hypotenuse, then cos 30 degrees will be z over y, and tan 30 degrees, because it is a right angle triangle, will be equals to x over z. So as important as all these concepts is, what if we want to evaluate, or what if we are given these three sides, we have theta, and we are given x, y, and z. Of course, we know that sine theta will be the opposite x divided by the hypotenuse y. Cos theta will be the opposite z. Will be the adjacent z divided by the hypotenuse z, y, and tan theta will be the opposite x divided by the adjacent z. The question now is, we were given theta here to be equals to 30. Now we're asked to evaluate theta. Let's say x is equals to 1, y is equals to 2, z is equals to 3. The question now says evaluate theta. How do we go about this? This is where the concept of inverse trigonometry come into place. Now let's take a look at it. We understand from our previous expression that if we have sine, let's say sine theta is equals to x. Yeah, let's do it that way. Sine theta is equals to x, and we are asked to evaluate theta. Or let's say cos theta is equals to y, and we are asked to evaluate theta. Likewise, tan theta is equals to z, and we are asked to evaluate theta. How do we go about it? Now, we know that when we have, let's say 3x is equals to 1. I want to evaluate the value of x. X is equals to 1 over 3. Now, the question now is, what is the inverse of x? The inverse of x. So the inverse of x will be known as x inverse. That's x to the power minus 1, which will be equals to 1 divided by 1 over 3. And this will result into 3. Now, considering this, now we want to evaluate theta. Evaluating theta from here, given that sine theta is equals to x, we understand that this is a product. Therefore, we can say that theta is equals to x divided by sine, and this will be sine inverse, or 1 over sine multiplied by x. So this will be sine inverse of x. So now we can see the results now that x in itself, when we have sine theta is equals to x, we will have arc sine of x to be equals to theta. Now we can call this expression arc sine x, or we can also call it inverse sine of x. So let's take a quick recap now. With this understanding, let's analyze it together. Remember, we have sine theta is equals to x. We had cos theta is equals to y. And likewise, we had tan theta is equals to z. Or let's change it. Sine alpha, cos beta, and tan gamma. So with this understanding now, you understand that alpha will be equals to arc sine of x, or what we call inverse sine x. Similarly, beta will be equals to arc cos of y, or inverse sine of y. And finally, gamma will be equals to arc tan of z. Now, we understand that when we were in quadrant section, where we had 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. So we're able to depict the range of the first quadrant, the second quadrant, the third quadrant, and the fourth quadrant. And now we can come to a conclusion based on derivation that the range of alpha, okay, is going to be between the values of minus 90 degrees to 90 degrees. So we are saying that alpha can be greater than or equals to 90 degrees. Minus 90 degrees can also be less than or equals to 90 degrees. Now, this similar concept works for all other inverse trigonometric functions. And this means that beta will also range from minus 90 degrees to 90 degrees. Therefore, we are saying that beta will be greater than, or it can be greater than or equals to minus 90 degrees, and also less than or equals to 90 degrees. Same thing applies to gamma. Gamma is going to be minus 90 degrees to 90 degrees. And this function implies the same thing, greater than minus 90 degrees and less than 90 degrees, less than or equals to 90 degrees. So we are considering both the negative angles and the positive angles, both the negative angles, positive angle, negative angle, and positive angle. Now, in some textbooks, you will see that it is written as minus pi over 2. Minus pi over 2. Now, why is it pi minus pi over 2? You will see, remember from our first lesson video where we introduced ourselves to trigonometry, that's 2 pi radian, where we're converting from radian to degree and from degree back to radian. So we call that 2 pi radian is equals to 360 degrees. Okay, now we want to evaluate what is the expression of 90 degrees. So if we divide by 4 and divide also by 4, this will result into pi over 2 radian is equals to 90 degrees. So we can see 90 degrees, we can see pi over 2, 90 degrees, and we can also see pi over 2. So therefore, if we reciprocate this in terms of radian, we will have minus pi over 2 less than equals to beta less than or equals to pi over 2. And the same thing applies to gamma, where we have minus pi over 2 less than or equals to gamma less than or equals to pi over 2. Also, we have minus pi over 2 less than or equals to alpha less than or equals to pi over 2. Now, this is the concept we are using in inverse trigonometry, where we will have sine of an angle is equals to a number, then the angle itself, when we ask to evaluate the angle, will be arc sine of the number or the result. Cosine of an angle beta is equals to the result y. If we are given the result y and we want to evaluate the angle beta, therefore we are saying that beta will be arc sine of the result y. tan of an angle gamma is equals to the result z. If you are given the result what z, we are given the result z, and we are asked to evaluate the angle gamma, definitely gamma will be the arc tan of the result z. So let's take just quick examples in applying both sine, cosine, and tangents in their inverse form. And this time we will be using, let's use the special angles. We remember in our special angles that sine 30 degrees is equals to 1 over 2. We also remember that cos 60 degrees is equals to 1 over 2. And which other one? Let's start with these two. And let's say tan 45 degrees is equals to 1. Yeah. Also, we understand from trig identities that cos 30 degrees is equals to root 3 over 2 sine 30 degrees, or let's say sine 60 degrees is equals to root 3 over 2, and this is undefined. Now, given that, now let's evaluate. Let's give the question that's given sine theta is equals to 1 over 2. What is theta? Now, automatically we understand that this is a question on inverse trigonometry, because we are saying that the sine of the angle theta is equals to the result 1 over 2. Now we are looking for the angle theta, but we are given the results. So definitely it brings us back to this place where we say that the angle will be the arc sine of the result. Let's write that. Angle is the arc. It can be the arc sine, it can be the arc cos, it can be the arc tan of a result. So applying this concept now to this question, we will say that the angle will be the arc sine of the result 1 over 2. So this will be the arc sine of 0.5. If we use our tables or if we use our calculator, we will have our answers to be 30 degrees. You can see theta is equals to 30 degrees, and definitely we are saying that sine 30 degrees is equals to 1 over 2, which is the same thing that we have here. Let's take another example. The question says find alpha when cos alpha is equals to root 3, or let's say 0.8660. Now remember that we are given the angle, we are looking for the angle, and we are given the results. Therefore the angle is simply going to be arc cos. Remember this time we are dealing with cosine, so it will be arc cos, that's cos inverse of 0.8660, and doing this we will have it to give us 30 degrees also. So we are saying that cos 30 degrees is equals to 0.8660. Converting this to sword, we have 3 over 2, and this we have here. Let's take a new example. Maybe we'll just pick a random number and we're asked to evaluate the inverse cos, or let's say the inverse sine, as the case may be. Now we have to evaluate beta when cos beta is equals to, let's say, 0.2588. Now you can pause the video right away and give this a try. All right, I believe you paused the video, so let's continue. If cos beta is equals to the result of this, definitely beta will be the inverse cos, or a cos of 0.2588, and this will result into 75 degrees. We use our calculator and punch in cos 75 degrees. We'll have 0.2588. Let's take a final question on, let's say, tan degrees. We're asked to evaluate, let's call this x, when tan x is equals to 1. We are asked to evaluate x, okay, when tan x is equals to 1. And the questioner says, leave your answer in radians. Yes, you know that you can evaluate x when tan x is equals to 1, but more importantly, leave your answer in radian. So let us first evaluate this in degrees. X will be equals to the arctan of 1, or the inverse tan of 1, and this will give us 45 degrees. Now let's recall back to our first lesson video where we are converting from degrees to radian and from radians to degree. Now remember, we want to convert 45 degrees to radian. Our basis of conversion will be equals to 2 pi radian is equals to 360 degrees. So we want to find an expression for 1 radian. So that means we're going to divide both sides by pi and divide both sides by 2 pi. So we're saying that 1 radian will be equals to 180 over pi. This is from radians to degree. Similarly, if we divide both sides by 360 degrees, we have that 1 degree is equals to pi over 180. This is from degree to radian. Now we want to convert 45 degrees to radian. Definitely, we are going to multiply it by pi over 180 degrees. So dividing this by 180 degrees, we'll have that our 45 degrees is pi over 4 radian. So x is equals to 45 degrees, which is also equals to pi over 4 radian.